Okay. So we'll finish up 1.2 problems, 1.3. We'll get through hopefully all of it today, and 1.4 intro, little intro today. If we don't get to it, we do it on Thursday. The quiz on Thursday is on 1.2 and 1.3. A little bit more about that at the end of class. Next Tuesday, 1.5/1.6. We'll see how much has to overlap. And then next Thursday, 1.6, 1.7. And then Thursday next week, a quiz on just 1.4. Now, what we did last week was examples of 1.2 homework through 23. When we left off right here, I believe 25. Let me check my notes. I used to know what was going on. I don't have a clue anymore sometimes. Yeah, we left off at 25. And find an example, find an equation of a line that passes through the given point, has the indicated slope. Schedule a line by hand, use graph utility to verify your sketch if possible. Okay, again, you're not going to need to show me your graphing utility, your graphing calculator work. Awesome. Okay. It's just so nice to see somebody goes to class. And this godforsaken and the rest of the areas. Okay. I was having flashbacks to my childhood. That's all right. I got to make an appointment with the therapist. All right, so 0 to 25, 6.7, do 29. Yeah, okay, 29. 6, -1, and the slope is undefined. Okay, so when you want to write the equation of the line, you need to know slope. Slope's the most important thing. Gotta have slope. Gotta have the slope. Unfortunately, slope's undefined. No slope for you. You can't plug slope if it's undefined. You can't plug something undefined into an equation. It just doesn't work. You need to remember that an undefined slope means vertical line. So special case. Those are the good ones. A special case means there's really not a lot of work you can show, but it's really easy to get it wrong if you're not paying attention to what you're doing. So on 29, 6, -1, this would be the work I would, if you needed to show something, this is what I would hope you would show. 6, -1 is in quadrant 4, over 6, down 1. 6, -1. Because the slope is undefined, it's got to be vertical. So it has to go like this. It is gave me this pen. So hopefully remember, since it's a vertical, it's just x equal to a constant, no y in the equation. That's why I rewrote on the board over there all of the 5 different ways you can write the equation on the left. I'll pan over a little bit, Charles. But the reason is x is always the same number. Everywhere on this line, the x's have to be 1. the x's have to be 6's. It doesn't matter what the y's are. That might be 6, 8. That might be 6, 5. This would be 6, 0. That's 6, -1. This could be 6, -13, for all we know. But the x's are all 6's, so what defines the line is just x is always a 6. You can't plug it into the equation. You just need to know what's being described is a vertical line. When the slope is 0, that's a horizontal line. When it's horizontal, y is always the same number. So if you try to do this without showing a picture and you know what you're doing, hey, slope is 0, that's horizontal. If it's horizontal, it's y equal to a number. What is the y coordinate in this order pair? Yeah, so the equation on number 32, y is equal to -8.5, and you're done. If you know what you're doing, recognize that's horizontal, y by itself. What does the y equal? -8.5, I'm done. Now, you know what I see students do? They'll write y equals 2.3. Because they get it mixed up when they're trying to put all the pieces together in their head. Or they mix it up. Oh, special case x equals. And instead they'll write x equals instead of the y equals. So the best way to not get it mixed up, make a picture. So you know whether it's horizontal or vertical, and you know which one is always the same. That's the best way to get it right. Because it's the easiest one that you could do, yet it's also the easiest one you can get wrong. So moving on, 25, we're done, 9, 31, 31, skip 33, do 35. And by the way, this one right here, this x equals 6, you can't, and that's why they said on the directions, you can't plug that into a calculator. Because the equations on a calculator, y equals, that's set, you can't change that. You, for vertical, x equals, you can't do it.
Do you want us to like graph everything? Or is it just
Well, the directions did say graph it. So it said, using that given information, just by telling you a point and the slope, sketch it by hand. So the point was 6, -1, and the slope was undefined. So you should be able to sketch that by hand. And then, you know, again, whenever it says verify, anything you do on a graphing calculator, you really can't, unless you're going to send me a, you know, a GIF, I don't know what, you don't have to, you know. You don't have to show me the graphing calculator stuff. Okay. But I show you the stuff up here so you can learn how to use it. That everybody does.
Okay.
Yes. 23.
I have a question actually on 11. Also, this might piss you off because you know this. Do you all use notes in the page?
This is, yeah, absolutely. Open note, whatever you want to have open, fine, except no internet devices.
Right.
But
What about
test is just you, a pencil, and a test. Not even scratch paper. So 11. I thought I did 11. Okay. Sketch the line to the point where the indicator slopes on the same. Okay, let's look at it. Yeah, I don't, maybe I didn't. So if I was going to sketch it, I'm going to pull up my special graphic. Because that's got, it's bigger. The point is 2, 3. So I'm plotting the point 2, 3, so 2 to the right and 3 up from the origin. 2, 3, right here. Whenever you graph something, I expect that you label the points that you're graphing. If it's on an axis, like I told you, you can just label it with a single number, like a number line. But when it's in a quadrant like this, ordered pair, so 2, 3. All right. The first one they want us to draw is the slope of 0. So slope of 0 is horizontal. You take a straight edge and you draw a horizontal line through that point. That's the good one. Now there's my horizontal line. And they want us to draw the other ones on the same axes. Now, so I can tell which ones are which, I can label this red line with, that's my slope of 0. Okay, now, every time you graph a line, I expect to see 2 points. That's only 1. So even though it's horizontal, I still need to see 2 points. I don't care where you put the other one. Basically, tell me when to stop. So I stop right here. There's 2 points on a horizontal line. That one right there is 5, 3. So 2 points. Maybe you stop there, or maybe you label this one, which is at the origin. Label that one just with a 3. I just need to see that you plotted and labeled 2 points. That's all. That's it. Okay. The next one they want is the slope of 1. So the slope of 1. Now, for slope, I need rise and run. I need to know directions on how to go from my point to the next point. Make a fraction. So what can 1 equal as a fraction? 1 over 1. So we're going to write my 1 as a rise of 1 and a run of 1. So from this point of 2, 3, I'm going to go up 1 and over 1. And that would be the next point on the line. Label the location of this point. Now, the slope is not the location. The slope is the directions on how you got there. The location is the address of where you're at. If I told you how to get to my house from here, go over 99, okay, go south, go east on 180, get off on Chestnut, go north on Chestnut, that's not the location of my house. The location of my house is the address of my house. Or even better, the GPS coordinates of my house. That's the location. That's the ordered pair, not the directions. So this ordered pair is 3, and the y is a 4. So it goes from 2, 3, and then it goes through 4. We'll draw this one. And also last week I said when you draw a line, make sure you put your arrows on it because lines go forever. Okay. Next one, we want a slope of 2. So a slope of 2 as a fraction would be 2 over 1. So the rise is 2 and the run is 1. Thank you very much. I'm at the wrong point. I started from 3, 4. 3, 4 is not the original point. And this is why, when I do these on the board, I have the benefit of working in pretty colors to help me distinguish between which one is which. And it's a little bit harder if you're working, the same color pencil. So from this point 2, 3, I go up 2, 1, 2, and over 1. And I'm going to move my ordered pair 3, 4. Here, so it's out of the way. And the location of where I ended up. So I was at 3 when I went up 2, the y coordinates of 5. I was at 2 when I went over 1. I'm now at a 3. So this is an x of 3 and a y of 5.
Oh, wrong one.
That's okay. And also, I can also label this. This was my slope of 1. And this one right here is my slope of 2. Horrible arrow. And then the last one is the slope of negative. So for a -3 slope, again, we want a fraction. Now, the denominator would be a 1. So this technically would be the same as -3 over 1. Negative, and then a 3 over 1. That's what -3 is. You need to know rise over run. So you need to put that negative either in the numerator or denominator. I will always consistently, because I think this works best for me, I'll put it in the numerator. I'll put, if I have a negative slope, I put the negative in my numerator and leave my denominator positive. Okay, but just so everybody understands, because not everybody always knows this. A fraction like -5 over 3 is exactly the same as if you just put -5 over +3, or if you put the negative in the denominator, +5 over -3. If the fraction has one negative, it's a negative fraction, it's a negative value. So it doesn't matter where it is. But because you're counting the slope, you need to know, do I go up or down? Do I go left or right? I always put it in the numerator. That way my first move is either up or I go down. My denominator is always going to be positive, always. So I'm either going to go up and to the right, or I'll go down, but then I'll always go to the right. So my denominator is positive, I'll always go right. I'm either going to go up or down first. It doesn't matter. I can do it either way. And I'll show you. So we start here, okay? And we're going to go down 3. So we go down 1, 2, 3, and we go right 1. So if you work into the green, down 3 and a right 1. So -3 is a slope. And I end up at this on the x-axis at 3. Since it's on the x-axis, I can just label it with a single number. And I'm going to graph that line. And it goes right through here. And this is the one with the slope of -3. But make sure you see that this is the same as going +3 over a -1. If I would have gone up 3 and then left 1, if I would have gone 1, 2, 3 up, 1 to the left is still going to be on the line. It has to, because it's like a staircase. The slope is like a staircase going, taking you from one point to the next, rise over run. Just when you have a negative, be careful when you put the negative. I just tend to do it always in my numerator. And the other one was 13? No.
Oh, that.
You said
you
11 and then,
answered my question.
okay, so you're good?
Yeah.
Okay. 35. Determine the slope and the y-intercept, if possible, of the linear equation. Then describe, you don't need to graph it, just describe the graph. So typically in the real world, you're given equations of lines in standard form. Like 35, 37, 39, 41. Standard form, 2x minus 3y equals 9. So that first one, that ax plus by equals a constant c. X and y are on the left-hand side together, numbers by itself on the right side. Just by looking at standard form, you have no idea where the first point is and how to get to the next one. You can't tell exactly, you know it's a line. That's what you can tell. It's an x to the first, it's a y to the first, we know it's linear. But we don't know points or slope or how to get anything. That's why I'm going to be sticking with slope-intercept form. If you have slope-intercept form, you automatically know exactly where one point is and how to get to the next point because you know what the slope is. So to get slope-intercept form, and that's what they want. What's the slope and what's the y-intercept? What's the m and what's the b? All you have to do is solve for y, get y by itself. So subtract 2x from both sides. Now, biggest mistake students will make, the next thing they bring down, they just bring down 3y. It's a negative 3y. Be careful and keep track of your signs. That's one of the biggest mistakes I see students make. They just forget and are going too fast. The next one, because they see 9 minus 2x, they'll make a 7. Well, 9 and 2x are not like terms. You can't take a 2x away from a 9. The other one is this, laziness. Oh, this drives me crazy. They know they got to take 2x away from both sides, but they just too lazy to write the x. I mean, in their heads, they know what they're doing. It's like, oh, come on, you know, do I have to write everything down? I take off points because 2x minus a 2 is not 0. Okay, I'm not going to grade what you think you saw in your head. I'm going to grade what you wrote down on the paper. So minus 2x, and then this. This is 9 minus 2x. But remember what you're after. You want y equals mx plus b. You want x and then the constant. So even though it's 9 and then minus a 2x, the best way to write it is negative 2x and then plus 9. To keep the order ready so you can identify the slope and the y-intercept. Okay. Then we divide everybody by negative 3. Now here's the other mistake. So divide by negative 3, and then I see this, divide by negative 3. Which, the way this is written is not incorrect. But then they try to simplify this over here. This only simplifies if you have a common factor that 3 goes into evenly. So you would have to show me that you have a common factor that 3 can go into, and 2, 9, and 3 don't have a common factor. So if you write this, it doesn't reduce. Okay? You can't just start crossing things off. So here's what I try to get students to do. If I multiply one term by, divide by negative 3 on one term, everybody gets their own negative 3 to divide by. Basically, I'm splitting up the big fraction. I'm splitting up the big fraction into individual fractions. And now those individual fractions reduce individually. A negative over a negative is a positive. and this is positive 2/3 x. A positive over a negative is a negative. 9 divided by 3 is 3. So the slope is the coefficient of x. So the slope they're looking for is 2/3. And the y-intercept b, which is after the x, is a -3. (42). 2x minus 5 equals 0. Big timeout. 2x minus 5 equals 0. Do you see an x and a y? Nope. Just an x. Just an x. And when you have only an x or only a y, special case. That's got to start sending some kind of fireworks going off in your head, bells ringing. Hey, x by itself, y by itself, those are linear special cases. One of them's horizontal, one of them's vertical. So this right here has no y in it, just an x. So therefore, this is our vertical line. How do you get it? How do you just get x equal to a number on that side? Well, let's add 5. And you get 2x equals 5. Divide both sides by 2. So this x is 5/2. And since it's just an x equal to a number, that means it's a vertical line at 5/2. If it's vertical, find the slope. For 42, the slope would equal undefined. The y-intercept, well, if it's vertical, it's 5/2. Now 5/2 times divided by 2 is 2.5, 2.5. So 1, 2, 3. So right here, that's where 5/2 is. It's vertical right here. So tell me when to stop. So if I stop right there, that point is also at 5/2, and that y is a 4. And if you just made a quick sketch, this is what it would look like. It's vertical right here. And if it's vertical, what is the y-intercept going to be? Where's it going to cross the y-axis? Like this. It's not. Because it's what to the y-axis? Parallel. It's parallel to the y-axis, so it's not going to intersect the y-axis. So it doesn't have one. So the only one that does not have, does not have a y-intercept is the vertical. Now, when does a vertical have a y-intercept? When the vertical line itself is the y-axis. Then the y-intercept is every single point on that vertical line, because the definition of y-intercept, when a graph intersects the y-axis. A vertical line intersects, they share the same points, the y-axis at every single point. Okay. That takes care of that group. Seven. On. So the next step, the next one, 43, 45, 47, find the slope of the y-intercept again, then graph it like I was doing. So what I just showed you in the last set, you're doing here. Oh, look at 45, 5x. There's no y, 5x and a -2. Oh, over here, 42. 2x and a -5. I think I see a pattern. I don't know if 45 actually falls, every other odd at that point, but. Okay. 49, you're supposed to find the equation in slope-intercept form using just the picture. So this gives us a chance to take it through all of the steps. So we want y equals mx plus b for this line right here. And the only thing we are given as certainties is that it goes through this point at -1, -7, and it goes through this point at 1, -3. Now, when it says find the slope intercept, we want y equals mx plus b. So it's like a puzzle. You got to find the m and you got to find the b, and then you write the equation. Step 1, find the slope. Well, sometimes they give it to you. Sometimes you got to go find it. Since I have 2 points, I have to find it. Subtract the y's, y sub 2 minus y sub 1 over the difference in the x's. Subtract your x's, x sub 2 minus x sub 1. So which y coordinate do you want me to start with? The -3 or the -7? -7. So if I start with -7, this y, minus that y, which is -3, divided by x sub 2. If I start with this y coordinate in the numerator, then I have to start with its ordered pair little buddy right here in the denominator. -1 minus that other x, which is positive. So my slope of the line is -7 plus 3 over -2. -7 plus 3 is -4 divided by -2. Always reduce to lowest terms. A negative over a negative is a positive. 4 divided by 2 is just 2. The slope of this is 2. Okay. Not a special case. It's not 0. It's not undefined. So the next thing I'm going to do, since I want y equals mx plus b, is I tend to write, this is what I'm trying to figure out, y equals mx plus b. It's, again, like I said, it's a puzzle, and I'm trying to find the m and the b, the pieces that make the puzzle work. If I don't have the box with the puzzle, the picture of the puzzle that I'm trying to put together, if I don't have that out on the table, then I have no idea what I'm trying to make. So that's why I write down the formula that I'm going to plug it into. Plug in the slope. And we're almost done. We just have to figure out the last piece. What's the b? Well, think about it. We just have right now y equals 2x plus b, 3 variables, y, x, and b. If you have 3 variables and you want to find one of them, you have to plug something in for the other 2. You got to plug values in for the other 2 to figure out the third. If I only knew the value of an x and a y that was on this line, well, they gave me 2 to choose from. This ordered pair is an x and y that makes the line work. And that ordered pair is an x and a y that makes the line work. So I'm just going to pick one of those and use it for x and y, then I can solve for b. Which one do you want me to pick? This first one or the second? Which one?
One.
So the first one, the positive one. Let x equal 1 and y equal -3. Substitution. Going into y, -3 equals 2 times x, 2 times 1, plus b, -3 is equal, 2 times 1 is 2, plus b. Subtract 2. Negative minus 2, -5 equals the b. So this missing y-intercept is a -5. Y equals 2x, and then a -5. Now, you could have said, hey, isn't it going through -5 right here in the picture? Can I just use that? Maybe it's 5.1. Maybe it's 4.9. Just because it looks like it's -5 doesn't mean it is. Never assume unless you are actually told these are the only ordered pairs. Those are the only values you were actually given. You cannot just look at something going, hey, that looks like it is. That's not going to work. Okay. Okay. So what I just did is just how you do 51 right here through 59. Okay. The only difference is you're not given a picture. You're just given the two ordered pairs. Fractions. So you pick 55, 57, or the decimal 59. I'll do one of those.
57.
57, of course you do. And by the way, I'll give you 5 seconds to do number 51 real quick. What's wrong? Oh, my bad. I picked wrong. I'm sorry. 53, 5 seconds. X equals -8. Vertical line. How do you know? That X is the same as that. Since the X's are the same, they are going to stack up on -8. It has to be vertical. If you try to calculate the slope in the denominator, x2 minus x1, -8 minus a -8 is going to be 0, and you're going to get undefined. It's amazing what you're capable of accomplishing when you pay attention to what you're doing before you actually try to do something. You actually look at something and think before you make your first move. You ever hear somebody tell you, why don't you think before you talk, before you open your mouth? Sometimes think before you start a problem might save you a lot of pain, effort, and misery. If you ever play chess or checkers, don't you like leave your hand on the checkers or leave your hand on the chess before you say, I'm good? Because you got to think through what might happen. Play it through just a little. Before you start, both X's are the same, vertical line. Over here, both of those Y's are the same, so that must be horizontal. Y equals 6. Okay. $57. How do we handle fractions? Well, we're going to need some slope. Fractions get to be points, they get to be answers. Equal opportunity problems. So we are going through -1/10, -3/5, +9/10, and -9/5. Well, that's convenient unless at least they give you some common denominators to work. Slope. Y sub 2 minus y sub 1 over x sub 2 minus x sub 2. I'm just going to start with -9/5. So in my numerator, -9/5 minus negative, parentheses, -3/5. In the denominator, I start with this y, I start with this x down below. 9/10 minus negative 1 over 10. Consecutive negatives. This is negative 9/5 plus 3 over 5. This is positive 9 over 10 plus 1 over 10. Negative 9 plus 3 is negative 6 over 5. Oh, 9 over 10 plus 1 over 10 would be 10 over 10. What's 10 divided by 10? 1. So this is just negative 6 over 5 divided by 1, which is just the slope of negative 6 over 5. But so many students will just say, oh no, fractions, I'm out. I'm not even touching that one. Okay. Calgon, you know, Calgon. There used to be commercials going up where somebody would have a stressful day, so they would pour this into their bath. Calgon, take me away. And it was supposed to be soothing and relaxing. These days, you guys have bath bombs and things like that. I don't know. I just know if you give that stuff to my wife, my daughter, they're happy. I don't put, try to do, never do this. Put this in your dog's bath water. The dog's home. Still got to find the equation of line. So it's not a special case. Y equals mx plus b. I'm really not trying to be funny. I'm just trying to like cut up the, you know, the monotony of me gabbering up here. So your silence doesn't hurt my feelings, but it's okay. I get what you got. Y equals negative 6 over 5. Don't know what b is yet. That's all for b. And again, I choose not to use the point slope form, even though point slope form is a direct, here's my point, here's my slope, plug it all in. Well, there's going to be different answers. Some of you might use one point and not simplify, and other people might use the other point and not simplify. But if you have to write it in slope intercept form, this takes me exactly to the final answer. And I don't have to worry about trying to simplify it. Pick one of those order pairs. The first one with the negative 1/10 or the second one with the positive 9/10. Just pick one of them. Check it. So I'm going to use that positive 9/10 and the negative 9/5 as my x and y so I can solve for b. And this is, you're going to have to get used to what I choose to do to help you understand, because if I didn't do this, that x equal 9 of 10 and y equal negative 9/5. If I just went and plugged them in, you know, somebody was just waking up in the back and go, what happened? Where that 9/10 come from? Well, hopefully we pick up what happened. Going for y, negative 9 over 10 equals negative 6 over 5 times x, which is positive 9 over 10, plus b. Before you can solve for b, you got to simplify this multiplication problem right here. Negative 9 over 10 equals negative times a positive, going to be a negative. Now, does 5 simplify a 6 or a 9? No. Does 10 simplify a 6 or a 9? Yes. 6 and 10 have a common factor of 2. 2 goes into 10 5 times. 2 goes into 6 3 times. So when I simplify that, I get negative 27 over 25 plus b. Okay. Multiply fractions straight across, numerator, numerator, denominator, denominator. Now, if you didn't simplify fractions there, you just have to simplify fractions when you're done. It's all fine, it'll all work out. Now you have to do something you may not want to do. You have to undo negative 27 25ths, bring it to the other side. Add 27 25ths to the other side, which means you got to get a common denominator so you can add these two together. Or if you don't want to deal with fractions when you're trying to solve an equation, you can undo the fractions before you do the addition and subtraction. Fractions are there because there's a denominator. A denominator means division. If you want to simplify a fraction, use multiplication. So the way I'm going to simplify this is I'm going to multiply every term by the least common denominator. If I multiply everybody by the least common denominator, it'll reduce. Now, 10 and 25. The first number that 10 and 25 both go into evenly is 50. Okay. 25 goes into 25, but 10 doesn't. The next number 25 will go into is a 50, and 10 goes into a 50. So I'm going to multiply everybody by a 50. It's like being on that last Oprah show. You get a car, you get a car, you get a car. You're going to multiply everybody by 50. You get multiplied by a 50, you get multiplied by a 50, and this one, everybody gets multiplied by a 50. What I just did was this. I multiplied the left side by 50. And what I did was I multiplied the right side by 50. But I noticed after all my years, students are so lazy about putting parentheses. And if they don't put parentheses, they forget that the 50 distributes to both. So they don't distribute the 50 to everything. So when I try to teach this, I just say everybody has to get multiplied by. If you multiply one, you got to multiply everybody to take away that possible mistake. So now this reduces. 10 goes into 50 5 times, 5 times -9, -45 equals. 25 goes into 50 2 times, +2 times -27. That's going to be -54. And then plus 50 times b. Add 54 to both sides. -45 plus 54 is +9. Whoops, 50. Then we divide everybody by 50. So the y-intercept, b, is 9/50. So that's what I would need right here is 9/50 to complete the equation. Y equals -6/5 x plus 9/50. Now, let's just, for all intents and purposes, verify this with a graph calculator. So the equation I have for y is -6/5 x plus 9/50. So I have a negative
negative. And then 6. Now, I tend, again, my OCD tends to put, makes me go a little parentheses back, because I want to make sure that nothing is taken to that. So negative 6 over 5, and then my x, and then I'm going to have plus my 9 over 50, plus 9/50. So whenever I have fractions, to make sure everything is nice and as a fraction stays together. And you know why, you do something like this is because of trauma yourself as a child. So you must have fraction trauma. So my range or my domain is going to be from, I'm just going to go, well, here's what I want to do. I want to plug in one of these guys and show you that it works. So that and that, these are less, that's less than or in between 0 to -1, and that's less than +1. So I'm going to use x min of -1.5 to a +1.5. And the next scale of, well, let's just go 0.25. And then I'll tell it to do a zoom fit. So my y-intercept right here, this is 9/50, 9/50. And here's how I'm going to check to see if I got this right with my calculator. The ordered pairs that make this work are supposed to be -1/10 and -3/5. Okay, we have a serious problem. Nine-fifths. Now, I wish I could say I made that mistake on purpose to show you how to catch a mistake that you might make. I plugged in 9/10. It's supposed to be -9/5 for the y. I even wrote it down right there. And nobody said a word. I blame you. So here's why I know there's a mistake. I know my answer is right. But this ordered pair is not going to happen on that picture. Because when you plug in -1/10 over here, you're supposed to get a negative y value. It's got to be down here below, and it's not, so my answer is actually wrong. And where did my answer go wrong is because I used -9/10 instead of -9/5, which actually it's going to make this come out a lot nicer. Here we go. So -9/5 equals, this is still -27 over 25 plus b. What's the common denominator now? 25. A lot better than a 50. 25, everybody. 25, 25. 5 goes into 25 5 times. This is -45 equals, this is -27, and that's 25 times b. Add 27 to both sides. Now that's going to be -18 equal to 25b. Divide both sides by 25.
And the y-intercept should have been negative 18 over 25.
Minus. So I'm still gonna use the same domain, but I'm gonna redo my Zoom to. Much better.
So now if I let x equal negative 1/10 and I go to that calc check on the calculator,
If I go up here, I do second, and I check the calc value 1,
and I'm just going to let x equal negative 1/10.
so negative, and then 1/10. I plug in negative 1/10.
It says the y value is exactly negative 0.6. 3/5 is 0.6.
And if I plug in positive 9/10, so change that to the second point to see if it works there. Value, and I plug in positive 9/10.
Then this is negative 1.8. 5 goes into 9 once with 4 left over. 4/5 is the 0.8, so negative 1.8. This is the right answer. So that's how you check when you're dealing with decimals like that or fractions.
Would you accept this deliberating answer in decimal form? Like if I were to turn. the
So instead of
fraction-
18/25, you would put 0.72.
Yeah, I would just turn all fractions into like a decimal or something. Would that be acceptable?
You got to read the directions on every test quiz. Directions on test quizzes are more often than not going to say answers in reduced value only, decimals only when the directions say specifically use decimals, and make sure you round appropriately. So it's going to be fractions. Very rarely do I want decimals, unless it's irrational numbers and we're trying to approximate. If we're approximating, then we're doing decimals. But we need to break the phobia, the fraction phobia that students have. When you take this to the higher levels, you got to speak fraction. You have to be able to speak fraction. And I know, it can be intimidating, but math is a language.
It's just easier for me to do it that way, but.
But it ain't about easy, it's about learning. And sometimes learning and growth is uncomfortable. Okay. I'm still growing, and look how uncomfortable I am. Okay. All directions. Unfortunately. Doctor says I need to get in shape. I tell him, well, round is a shape. Do the best I can. The 61 land on that? 77, 73, 73, 69, 69, 65. So yeah, 61. Use the graphing utility to graph the equation using each viewing window. Describe the differences in the graph. So this would just be you graphing this equation right here in your graphing calculator. The first time you're going to set your graphing window to this. Then you set it to this, and then you set it to this, and you just
a little shorthand, what's the difference in the pictures? Okay. Right here, you're changing the width of the box and very little change on the Y's. But you're changing the width a lot. Okay, here you're not changing the X's, but you're squaring up the Y's, it looks like. So they just want to see what do you notice as the changes as you change the window. The window matters, your X max, Y min, Y max, when you're looking at it. Just because you're looking at it and it looks one way, that screen is rectangular. Doesn't mean that's what the graph actually looks like. When you have it as a rectangular screen, the units on the X-axis are not, they're not in proportion to the units the way they're measured out on the Y-axis. That's when you do a zoom square. If you do a zoom square, then it will sharpen up the image so you'll have X's and Y's, the little breakdowns, little units be the same for the X and the Y. And you'll get a zoom square means you're going to get a more of a honest depiction of what the shape looks like. But it's hard to get a zoom square unless you have the shape already within that zoom fit. You got to fit the screen first. Page 63, 65. 65. Are the lines parallel or are they perpendicular or is it even? Parallel lines, the slopes are equal. Perpendicular lines, the slopes are opposite and reciprocal. Okay. Now, I don't think you guys are going to have much trouble with this, but I know when I teach this in my 103 class, they struggle with knowing which one is which. Or when they do perpendicular, they'll change the sign, they'll do the opposite, but they won't flip it. So, parallel, slopes equal. Parallel lines has a couple of L's in it that look like parallel lines. If you turn those parallel lines sideways, it looks like an equal sign. Slopes are equal. If the slopes are equal, the lines are parallel. Okay. Perpendicular. The slopes are opposite and reciprocal. So you change the sign and you got to flip it. Now the symbol for perpendicular is like an upside down T, like a T-slope. Like a vertical that intersects a horizontal at a right angle, but that's a symbol for perpendicular lines. So, opposite. Horizontal and vertical lines go in opposite directions. Horizontal goes left and right, vertical goes up and down. Horizontal, vertical, that's a horizontal and a vertical. They go opposite directions. So you need opposite. And then reciprocal. This looks like a flipped over T. Flip it. I'm trying to give my 103 classes something they can grasp onto, because they struggle. No matter how many times I give them problems, this is going to be on your test, just like this. We're going to do this like this. So when you do this problem right here, the slope of the first line is 0 minus 6 over negative 6 minus 3. So that's negative 6
over negative 9. A negative over a negative is positive. Reduce it. 3 goes into 6 twice, 3 goes into 9 3 times. So the first line for line 1, 2/3. Now, I'm telling you, if you change that to 0.66666 repeating, and then how are you going to know the other decimal is going to be the same, I guess you know, opposite reciprocal? That's a decimal. I know you probably would look at it as a fraction, but I'm just saying this is why we stay with fractions. We want fractions so we know rise over run for graphing. If I gave you the slope as a fraction, if I gave you the slope as a decimal and you had to graph it, I hope you would convert it to a fraction so you could just do rise over run. So in other words, if I gave you, 0.6, well, that's 3/5 of 3 over 5. If I gave you 0.25, well, that's 1/4 of 1 over 4. If I gave you 0.11, that's 11 over 100, up 11 over 100. Some don't reduce, but that's what that is. But that's why we like the fractions, because it's about arc, it's about the direction from slope to this slope, 1 point to the next. Then this one, so for line 2, slope of the second one, 7/3 minus a negative 1. So 7 over 3 minus a negative 1 over 5 minus 0. 5 minus 0. Okay, so 7 over 3 plus 1 over 5. Now, again, here's fractions, so you can make a choice. Work with the fractions. And if I work with the fractions, in the numerator, I need a common denominator. So I'm going to change this 1 into 7 over 3. This is going to be 3 over 3, all over 5. So 7 plus 3, that's 10 over 3 divided by 5. Now let's reduce that. So understand this is what you've got. It's 10 over 3 over 5, which means this numerator is being divided by 5. So therefore, when you multiply, you divide, when you just said it back. When you divide, you multiply by the reciprocal. What this means, it's 10 over 3 times 1/5. So this 5 goes into that 10 2 times. 2/3 times 1 over 1 is 2/3. This is 2/3, the slope of line 2. And since the slopes are equal, where are we at? Line 1 is parallel to line 2. Okay. So that's a complex fraction. A complex fraction is when you have a fraction that has little fractions in it. Okay. Now there's another way to do that. And this is actually the way I prefer to do it, instead of working the fraction and then working more fractions. For slope 2. 7/3 plus 1 all over a 5. I just prefer to undo the fractions, the little fractions, before I start. And that just means I'm going to multiply the numerator and denominator by the same thing. So that means I'm going to multiply this thing by 1. But to do that, I want to multiply by something smart, a special 1. Something that will undo my fractions. So who's causing the problem? It's that 3 right here. That 3 is causing all the trouble. Since it's over 3, I want to multiply by 3. Well, if I multiply one of the terms by 3, I got to multiply everybody by 3. In other words, this is what I'm actually doing. I'm multiplying the numerator like this and the denominator like this.
by a 3/3. 3/3 is just 1. But again, lazy, they don't put parentheses, so they forget to distribute. So I just tell, hey, if you multiply one term by 3 to undo that fraction, make sure you multiply everybody by 3. Everybody gets multiplied by 3, and that takes care of forgetting to put the parentheses and forgetting to do the distribution. Now, this is 7 plus 3 times 1 over 15. No more fractions. 10 over 15 is 2/3. Okay. If you have like oh, 3/4 minus 8/7 divided by 5/2 plus let's go with 9/4. Yeah, 9/4. I hate making things up in my head that right to start because but there we go. None of those reduce. Nice. But I want to you'd have to get a common denominator for the top, get a common denominator on the bottom. Then you get a fraction over fraction that you got to now multiply by or so. Or undo the fractions at the beginning. 4 and 7, 2 and 4. Let's just start with 4 and 7. What's the first number 4 and 7 can go into? 28. The least common denominator for those is a 28. Now, can this 2, can it go into a 28? So 28 works for this one. Can a 4, this one over here, can it go into a 28? So 28 works for all the fractions. 28 would undo all of those denominators. So everybody's going to get multiplied by 28. This one gets multiplied by 28. This one over here gets multiplied by 28. Down here, don't forget, 28. Everybody gets multiplied by 28. Four goes into 28 7 times. 7 times 3 is 21. So we get 21 minus 7 goes into 28 4 times. 8 times 4, that's a 32. Over 2 goes into 28 14 times. 14 times 5, that's 70 plus. 4 goes into 28 7 times. 9 times 7, that's 63. No more little fractions in my fraction. 21 minus 32 is equal to negative 11 over 113. That's it. Okay. Undo the fractions before you try to simplify the fraction. Yes. Oh, that takes care of this. Write the slope-intercept form of an equation to the given point that's parallel to the given line and then perpendicular to it. I know I'm going to put one of these on. Seven, so that means we're skipping 75, we're doing 73, 71, 67, So I'm just gonna do, I'll do 69. We'll stick with the practice, common. Unless you want me to do 67. 71's decimal, I use 71 as well. 71, 67, or 69. You got it. We haven't done the one with decimals. Here's when decimals would be perfectly acceptable. If you're given decimals, then you can plug in decimals. So 71 goes through negative 3.9, comma, negative 1.4. And it's parallel and or partly perpendicular to 6x plus 5y equals 9. So 71A, we want parallel. 71B, we want perpendicular. Step one, you gotta have slope. It's parallel to this line. So if it's parallel to this line, this slope is going to be the same as that line. It's perpendicular to this line. So on this one, the slope is going to be opposite and reciprocal for the slope of this line. So the bottom line is, step one, you got to have a slope. To get my slopes, I need the slope of that line so I can get the slope for my lines. It's all about that line first. To get this slope, I'm going to move this higher. Solve for y. Subtract 6x. 5y equals negative 6x plus 9. Divide everybody by 5. So y is equal to negative 6 over 5x plus 9 over 5. So the slope of this line up here is negative 6 over 5. So the slope for my parallel line, my parallel slope. So this is what I'm going to use, slope, and then subscript the symbol for parallel. So that's my parallel slope is equal to negative 6x. And then over here, the slope for my perpendicular line, subscript, is going to equal opposite, so positive 5, flip it, over 6. Gotta find slope first. I found the slope. Parallel, I use exactly the same thing. Perpendicular, opposite, and flip it. Opposite and reciprocal. I am now done with this line. I don't need it anymore. Because I'm trying to figure out what's the equation that goes with this point right here. It's all about making the right equation using these slopes that go through this one. I don't need that anymore. It's like that. I've used this in the last few years because, again, you know, trials and trials. That girl in the sophomore year who asked me to Christmas formal used me and then dumped me after formal because she got what she needed. She got the slope that she needed and didn't need me anymore, so she threw me away and never heard from her. So I was the 6x plus 5y. Never need. Nothing new. Either that or just like you're going, oh, he really did. Oh yeah, sure she would. Yeah, well.
plug in the six this. And then the plus b, and then that's the x and y, you use that x and y. So we're gonna see if I can do this right. So x equals negative 3 over 3.9. And y is negative 1.4. Negative 1.4 equals negative 6 this times negative 3.9 plus b. Negative 1.4 equals. And this would be fine to go decimal here. Yeah, that's negative 1.2. So negative 1.2 times negative 2.9. But when you multiply this out, I have negative 4.68. Or positive 4.68 plus b, and then subtract 4.68. So that's going to give us negative 6.0. So the parallel line, y equals negative 6 this x minus 6.0. And then for perpendicular, y equals mx plus b, slope is 5 over 6. We're going to plug in the same ordered pair. Negative 3.9. Y is negative 1.4. And negative 1.4 is equal to 5 over 6 times negative 3.9. Plus b. And that's negative 3.25. Plus b, add 3.25 to both sides. And this is going to equal positive 1.85. So my y intercept here, y equals 1.3, y equals. And then, when you check it in the back, so one. So minus 6.08. But then again, they're using the fraction as a slope, and then the y-intercept is that decimal. Fraction 5 over 6. Oops, I'm going to get it wrong. I got off at x about 30. And then plus the 1.5. I know that I'm going over every possible iteration of what you're going to see in the homework. So I don't assume where everybody's at, if you're all on the same page. I want you to have an idea. I want you to have a clue. I could just say, all right, here's the lecture, go home, do the homework. If you don't ask questions, I'm just going to keep on going. I'm trying to stave off questions before you end up. It's just I'm trying. 77.
So the directions say, the lines are parallel, find the slope intercept form for line 2. Now, slope intercept form, they're giving you the slope of line 1, 2. So since it's parallel, the slope of your line here is going to be 2. Now, it looks like the y-intercept is 1. Try not to assume. Use this order pair to figure out the y-intercept is. But since that y-intercept is 4, I bet that this is going to be, no, if you have a slope of 2 and this is -1, -1, you go up 2 and over 1, guess what? The y-intercept is 1, just by counting. So if you think it through again before you even start, you don't even have to plug in the numbers. 85. Okay, a roof. The rise to run ratio of the roof of the house determines the steepness of the roof, the pitch of the roof. The rise to run ratio of the roof here is 3 to 4. Determine the maximum height in the attic of the house if the house is 32 feet wide. Sometimes when you see the whole picture, you get more confused than if you just look at part of the picture. You know, this is 32. You're supposed to figure out what is the maximum height at the very top of the roof. You're trying to figure out what H is. They tell you that the pitch of the roof is you go up 3, then you got to go over 4. Well, if I just do this. I don't need the whole structure of the attic. What I need is just one triangle that's in that picture. So when I do that to the picture, instead of 32 across, how far is it down here? Be right in half, 16. Okay, want to know what H is? Okay, now 3 to 4. That's a right angle. If you ever took a geometry class, you have heard hopefully of something called Pythagorean triples. Those would be triples, 3 numbers that always will satisfy the Pythagorean theorem. Pythagorean theorem, you got leg squared in the right triangle plus the other leg squared in the right triangle equal to the hypotenuse, the long side squared. 3 is a leg and 4 is a leg. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. So the opposite side of the hypotenuse has to be, if it's the square is 25, then this side is just 5. Okay. Ratio would just be 5. So if this little ratio here, now that's just a 5. Isn't this 16 the run? And isn't this H the rise? Yes or no? 3, 4, 5. This triangle has to maintain the same ratio as this one over here. So if the run over here is 4 and the rise is 3, then the run has to be a ratio of 4 across to 3 up. And then this would be some kind of multiple, and it would be a multiple of 5. Well, we get 16.
So what did they multiply the 4 by to make this a 16? This 4 is connected to this side. So what times a 4 makes a 16? 4. 4 times 4. So if I multiply that 4 by another 4 to get to 16, then this 3 over here has to be 3 times the 4 to maintain the same ratio. This is a 12. The height of the attic is a 12. Now, how long would the roof be? Because that could be another question. The hypotenuse is a ratio of 3 to 4 to 5. So the hypotenuse has to be a 5 if that's a 3 and a 4. So since you multiply the other side by a 4, you multiply 5 by 4, this would be a 20. Mhm. So okay, that's a pretty good approach too. That's a pretty good approach. So right here is the origin, okay? And so if you're maintaining a ratio of up 4 over 3, up 4 over 3, so y is equal to, sorry, up 3 over 4, up 3 over 4. 3 over 4 slope times x, and the y-intercept is 0. Now, because this is 32, what you want to know is, what does y equal when you plug 16 in for x? What's the y over here going to be? So y is equal to 3/4 times 16. 12. Because you would put it on the next y-axis and make a straight line out. That's another approach. Better to solve one problem 5 different ways than 5 different questions, 5 different problems. Another way to look at it, that right triangle right there is just invert, just flip it over. If I flip it over, it's right here. Where this, again, is the horizontal, so this is the ratio of 4, and that's the ratio of 3. It's 4 to 3 in that picture. So if that 4 becomes here a 16, you would have to multiply by 4 to maintain, or to get it to be a 16. And therefore, you have to multiply this 3 by 4, and that's why this is a 12. They keep the same rise over run of 3 to 4. Lots of different ways to look at it. 85. $89.91. 89. You are given the dollar value of the product in 2015 and the rate at which the value of the product is expected to change in the next 5 years. Write a linear equation that gives a dollar value D of the product in terms of the year T. And T, let T equal 15 represent 2015. What they're describing. And this is what you got to train your brain. They said it's linear. Write a linear equation. Linear equation, that means X's and Y's. Most of the time. But what it means is 2 variables, one variable and another variable. An ordered pair of one and another. In this case, write a linear equation that gives, so that would mean that's the dependent variable, because that's what comes out. That's your Y. That gives the dollar amount B. So B is what comes out, because that's what's going to be given, or that's what ends up happening. In terms of the year T, that means when you write an equation or a function,
in terms of X means it's got X's in it. In terms of T means that's what you started with, we're plugging in values of T. So your ordered pairs are T and then V's instead of X's and Y's. So here, you're given the dollar value of a product in 2015. So T 15 and it equals $2,540. This would be an increases. This is the slope. The slope is equal to $125 per year, every 1 year. So write a linear equation that gives a dollar amount V. D would equal, in this case, D equals M times T plus a y-intercept. Because you got to come up with a y-intercept. So V would equal 125 times T. I don't know what V is. And the way we solve for V in the other problems, we got to plug in an ordered pair so we can solve. Well, the only ordered pair I have is at 15, 2,540. The 2,540 is equal to 125 times 15 plus V. So 2,540 is equal to 1,500 and then another 525. So that's 1,750. No, 1625. No, I have no idea. Not good. Never guess. I'm just gonna feel foolish. 1875. Subtract. So the y-intercept, in this case the v-intercept is 125 times t plus 665. Can you take what we know and apply it to a different set of circumstances? And on 91, when it says it decreases, what's the change you would make? When it says it decreases, $2,000 decrease per year, what is that going to change? How would it change? The slope would be a negative 2,000 times t. Okay. And then if you still have questions about that, we can cover that on Thursday. And then 95 is another one of these money examples. Okay. With about the last 3 minutes I have left, or 4 minutes I have left, just a preview of 1.3. So here's your quiz. Your quiz is only going to be on 1.2. And I'll tell you right now. It's on 1.2, and I'm going to give you 2 problems. The first one, write an equation of a line. And slope intercept form, y equals mx plus b. And I'm going to give you 32 formulas. I'll give you 2 ordered pairs, and you got to come up with the equation of line. And then that's question number 1, and then question number 2. I'm gonna give you, if I'm giving you two equations, for line 1 and a line 2. Are those lines, are they parallel? Perpendicular? Or neither? Okay, so I will give you two equations. And the only way to tell if they're parallel, perpendicular, or neither is to compare the slopes. Okay. And real quick. Just a short walk right here. On Thursday, our lecture is going to be on function, introducing what a function is. Function is the connection for ordered pairs for x's and y's. Same, something goes in, x's, something comes out, y's. Now, there are lots of connections of ordered pairs. We have lots of ordered pairs. They're all called relations. There are certain relations between the given value and something that comes out. Special relations are considered functions. Every set of ordered pairs you come across is a relation. There are certain relations that are called functions if they satisfy a certain definition. Have to satisfy the definition first. And then only a certain amount of those functions actually satisfy another definition about whether or not they have an inverse. So we start to narrow down what some of these things can do based on the definition, which means it's based on a language. Bit by bit, piece by piece. Look at how this is worded. A function f from a set A to a set B is a relation that assigns to each element x in the set A exactly one element y in the set B. The set A is the domain or the set of inputs of the function f, and the set B contains the range or set of outputs. That's how a mathematician writes a textbook, which means he writes a textbook so no student can read that and understand it on their own. So it keeps me employed because I'm gonna come in, try to clean that up. Translate. Now, if you get it, that's great. But you got to make sure that we're clear about how it all fits together. If you are going higher in this stuff, this is where college, universities, this is what they dig into. It's all about this idea of definitions and sets. It's not about numbers. It's about the theory that holds along. Okay. I'm going to take the rule. Josh Aguilar. Okay, Jasmine Benitez.
Here.
Francisco de Leon.
Here.
Lewis.
Here.
Ryan Lira.
Here.
Marcelino. Marcelino. David Marcial. Daniela. Los Rios. All Rios. Valentine. And Kelsey. All right. Let's have a good one. Kelsey.
What?
You're not gonna.
Oh,
Don't worry about
I just
it.
asked a lot of questions.
That's okay. Listen, you guys have been silent most of the. I want.
You do have.
I'm up here trying to be act like a fool to get some kind of reaction.
Also, a question.
Yeah.
Is there a place on campus to get water? Fill up my water bottle?
Oh, to fill it up like water fountain?